Hey folks, welcome back to our next lesson. In chapter 2, we're going to be multiplying and dividing rational expressions. So you have simplified them before, and that will definitely be an important lesson to use here because we're going to be simplifying as well. And it's going to be great. It's combining two wonderful things about math, fractions and factoring, everyone's favorite. So without any further ado, let's get started with how to simplify rational expressions and how to check using Desmos. We're going to talk about how to multiply and divide rational expressions. Now, the majority of this is going to be on multiplication because we're going to see at the end division is just multiplication. And we got two methods of doing this. You can either first multiply the numerators of the given fractions and the denominators of the given fractions and then reduce. Or the second one, which I'll be blunt, I prefer the second one. You first factor, then you cancel, then you multiply the numerators and denominators. We always want to write it in lowest terms. And I'm going to show how to do both of these to begin with, and then whichever method you decide, that's up to you. Again, I prefer the second method. So, how to do this with just little old normal fractions. These are the same fraction each one. In the first method, you multiply across the numerator. So 2 times 3 is 6, 3 times 4 is 12. Then I simplify that as much as I can by saying 6 goes into this once, 6 goes into that twice, the answer is 1/2. You might say, okay, easy peasy, cool. Now, with method 2, you cancel first, and I can say, well, 3 and 3 are both in the numerator and denominator, they cancel out. Also, 2 goes into this once, 2 goes into that twice, so I'm left with 1 over 1 times 1 over 2, and then I just multiply 1 times 1 is 1, 1 times 2 is 2. Remember, even though I canceled out these two 3's with the green, I canceled them out. They leave me with these 1's. You can't just erase an entire side of a fraction. You gotta leave it. Now, you might be thinking, okay, cool, it's been a while since I saw this, but I got it. Here's how it's really gonna look in this class. We're going to do it with rational expressions. These look a bit more complicated, but they're not so terrible. So, method 1. We're going to do method 1 for the first, then method 2 for the first. First things first, I would just throw all these together, so I'd multiply across my entire numerator, 4x, y. Typically, we put these things in alphabetical order as well. And then 5 times 8 is 40, then x, y. Then we cancel out anything that's in the numerator and the denominator. The y's are going to cancel. The x's are going to cancel. And then I know that 4 goes into this once, 4 goes into that 10 times. Well, the only thing left is going to be 1 over 10. You could also put from the blues canceling out 1 over 1, and then the greens canceling out 1 over 1. However, you're just multiplying by 1 then, so it doesn't matter. Notice, however, in this our numbers got a bit bigger. We got a 40. Maybe you don't want to deal with that. That's where the second method comes in. Second method, same problem. First you cancel, so my x's cancel out. Then my y's cancel out. Whoa. Ah! The y's are not canceling. And then we look for the numbers. Well, 4 goes into this once, 4 goes into that twice. What I'm left with here, I'm going to rewrite it before I multiply everything together, is I'm left with 1 and 2 because of my 4 and 8. My green x's have canceled out, so I got a 1 and a 1. My blue y's have canceled out, so I have a 1 and a 1. And then I still just have my 5 hanging around, so my 5 goes down here. I just multiply across now. My numerator is 1 times 1 times 1, that's easy. My denominator is 1 times 5 times 2 times 1, so that's just 5 times 2, so 10. You might still be thinking, well, I definitely prefer method 1, I mean, it's so much easier. And that's perfectly fine, you can prefer whichever method you'd like. But this is where it gets a bit more wonky. You might be really, really tempted when you're looking at examples like this, the second example here, to say, well, first things I'm going to do is just multiply everything that I'm going to distribute. In fact, what a lot of folks would do is they do, okay, that's 12b plus 1 over 4 times 5b plus 5. Okay, then I'm going to distribute, then I'm going to do it. You don't want to distribute here. The whole idea here is to continue to break it down as much as humanly possible. So, I can't break down my numerator anymore. It's just going to be 12b plus 1. I can break down my denominator a bit more. That 4 is going to stay, but I can break down this expression using GCF. And that's going to become 5 times b plus 1. Again, that was just GCF. The other expression, I'm going to color code it so we know what's going on. And then we have a lot of stuff that can cancel out. The entire expression b plus 1 can cancel with b plus 1. We can also see that 4 goes into this once, 4 goes into this 3 times. So what I'm left with is 3 in my numerator, 5 in my denominator, and that's it. That's it. Now, let's take a look at the second method. Remember, the second method is you factor everything first before combining it. I can't factor the first fraction, so I'm just going to do that. I can factor the second by the 5b plus 1 and 12. You could factor the 12 out more if you'd like, that's fine. The b plus 1s cancel out. 4 goes into that once, 4 goes into that 3 times. Equal sign. And that means I'm just left with, my first one is 1 over 1. My second is 3 over 5. So that means it's just 3/5. Now we're going to check out how to check these using Desmos, because it is always a really good idea to be able to check your work before you hit submit on DeltaMath or turn in an exam. Do this and check using Desmos. We know our original was x plus 1 over 4 times, you can just put the little asterisk above 8 for times, 12 over 5x plus 5. All I've done is I've replaced the b's with x's so we can graph out. And then I'm going to do 3 over 5 as well. And, oh, I need a y equals there. It's the exact same thing. If I take out the 3 over 5, the red remains. Now, this looks like a straight line, and that's just because it's simplified down to a fraction, or just a number. There's no x or variable in our final answer, and that's fine. You'll see in later lessons that it's not really a straight line. There are some missing areas of it. For instance, if I were to look here at my table, I have an undefined value at -1, but we're going to talk about that later and why it exists. From here on out, I don't mind which method you use. I'm going to use method 2. But here are some more complicated looking examples. They're freak-out worthy looking, but they're not terrible. So let's just take a quick look at them. In this first one, I'm going to factor out my numerator. Actually, you know what? Let's just write down all the stuff we can't factor. All that stuff I can't factor anyway. I can factor this numerator, and I can factor this denominator. The red numerator is difference of perfect squares. So it's going to be a plus 10, a minus 10. The blue denominator is going to be GCF. My GCF is 2. What I'm left with is a minus 10. Well, now I just want to cancel some stuff out. I have a minus 10 in both of these. So that cancels out. I have a in both of them. For instance, this a cancels out here. Remember, a squared is 2 a's, so I can just cancel them out. And then I have nothing else that can cancel. So I'm just left with, my first fraction is a plus 10 over 3. My second fraction is a over 2. So I can just combine these things together to be a plus 10 over 6. I'm not going to distribute that a in the numerator just because I want this in fully simplified form, and that is fully simplified form. Let's take a look at the next one. Next one looks, oh man, a lot complicated. But we're going to work through it using what we know about factoring. So I know that this top one is a factors and sums. I want numbers that multiply to positive 4 and add up to negative 6. A minus 4, A minus 1. This bottom one is a GCF. There's a 3 there, so it's going to be A plus 2. This top one's also a GCF. So it's going to be GCF of 2, A plus 2. And then this bottom one, well, let's do it in a different color. Why not? Purple sounds good to me. This bottom one is a difference of perfect squares. So it's A plus 4, A minus 4. I guess we call that a lilac. It's nice. Goodbye, lilac. So now we just need to cancel some things out. I'm going to do this in highlighter, actually, so it's obvious what's being canceled out. A minus 4 and A minus 4 cancel out. Then I have A plus 2 and A plus 2 are going to cancel out. And then I don't have anything else that cancels, so I just bring it on down. So my first fraction is just A minus 1 over 3. You may notice I didn't write the parentheses around A minus 1. That's because there's nothing else in the numerator, so I don't need to separate it from anything. Then my second is just 2A plus 4. And I can just rewrite this as 2 times A minus 1 times 3 times A plus 4. And that's my fully simplified form. You might be thinking, but I can cancel those A's out. I mean, there's an A in the numerator and an A in the denominator. I can totally cancel those out. You cannot cancel them out because they're not being multiplied by anything. They're being added or subtracted to something. You can only cancel things out if they're multiplying something else. Work using Desmos. I'm going to check this one over here first, the first one we did. You'll notice that I plugged the first expression into Desmos. I replaced A with X, so it actually graphs out. If you don't replace it with X, you're going to get something saying insert slider. You don't want that. If I plug in my simplified form, it's the exact same thing. They're in the same area, so I'm good. I can also use it to check my second one. Oh, went too far. So I plug in my original. Gives us this weird graph, and a lot of rational expressions will look like this. We'll talk more about why they look like that in a later lesson. I plug in my second. They occupy the exact same space. Now, they're not exactly the same. For instance, if I go to making a table for each one of these, there are slight differences. However, for instance, one difference is this at negative 2 is undefined. Here at negative 2 is equal to negative 1. But we will get into that in later lessons and explore the graph just a bit more. Now, dividing rational expressions. You might be thinking to yourself, wait, we're just spending the last couple of minutes of this video on dividing? Yeah, because you're going to see in half a second just multiplication. You might remember keep, change, flip from previous math classes dealing with fractions. This is not my image. Image credit is right here below. GetEpic.com. So we're just going to show how to do this using keep, change, flip, even though I hate it. So I'm going to keep, change, flip up there as a reminder. First thing, I keep, I change, and I flip. Now it's just multiplication. So keep using method 2. 3 goes into this once, 3 goes into that 3 times. 4 goes into that once, 4 goes into that 5 times. So this is just equal to 1 over 1 times 5 over 3. So 5 over 3. This second one, still going to do keep, change, flip. The first one gets kept. We change the sign. We flip the next. And then we just do the same thing which we have been doing. Doesn't matter if you use the dot or the X, either one is fine. So this is going to be C minus 3, C minus 3. My smart board decided it didn't want to work right there. This is just going to be a GCF, 5, C minus 3. and then the rest just gets brought down. So we have 5 and c minus 3. So let's start canceling stuff out. I'm going to do it with the highlighter. I have a c minus 3 here. I have a c minus 3 here. They'll cancel out. I have a second c minus 3. I have a second c minus 3. They'll also cancel out. I have a 5. I have a 5. It also cancels out. Well, I got nothing left. This fraction has become 1 over 1, because remember, when we cancel out in a fraction, it turns to 1, not 0. This second fraction is also 1 over 1. Well, that just equals 1 over 1. You can rewrite it as just 1 if you want. One last thing about dividing. Wow, we're working with rational expressions, which are just fractions. But this first one isn't a fraction. What do I do? Well, you just rewrite it as a fraction. Remember, you can write anything as a fraction if you just put it over 1. Other than that, the problem remains unchanged. So it's just going to be 2x squared plus 5x minus 7 under 1. Well, let's just run through this one. Keep this the same. Change the sign. Flip this. Now, the really cool thing is, we've gone from a rational expression to, wait a second, I don't need to do anything here but box method. Because all of a sudden, I don't need my denominators, they're just 1. So this is just going to be 2x squared plus 5x minus 7 times 2x plus 7. FOIL won't work here, remember, because we just have too many terms. So this is going to be 4x to the third, 10x squared minus 14x, 14x squared, 35x, negative 49. And then we can just combine our like terms here. Like terms there. Like terms there. So 4x to the third plus 24x squared plus 21x minus 49. You don't have to factor that one, that would be horrible. We're done. Alright, you've watched that whole thing, you've taken wonderful notes, you're good to go. Now you're going to head on over to DeltaMath and complete 3 problem sets. So the first one is just multiplying and dividing with fractions. There's no polynomial factoring there. It's just, giving you some practice. You should be able to knock that one out pretty darn quick. The second one is multiplying and dividing rationals level 1. It should give you a tiny bit more work with it, but it's alright. The second one, multiplying and dividing rationals level 2. Don't be intimidated by these problems. Their bark is much worse than their bite. And you can always check using Desmos before you go and hit submit. That way, you can look for an error. After that, you're just going to do the lesson summary, and then you're going to read section 2.4 in the textbook and complete the reading summary below. Again, you should be able to do the video and at least the first DeltaMath problem set in the class time we have. If you have any questions right now, head on back to Live Gallagher. He will answer all of them. Digital Gallagher, signing out.